One of the questions I asked you to answer was to determine if the number of candies found in the bags from all of the data sets followed some form of a normal distribution. We didn't get a chance to talk about histograms in class the other day, so here's a quick Excel tutorial on how to create a histogram. What I've got here is a copy of the all M&M data, which you can find on the Moodle website. Just open it on up and you get the various bags from the groups and the colors of candies found in each one of those bags. The first thing I would like to do is calculate the fraction of candies found in the particular bag. And I'm just going to do this for blue, and I'm going to leave you guys to figure out how to do it for the remaining colors. Start off with labeling a column the blue fraction, and the equation that we'll put in here is the number of blue candies divided by the total number of candies found in that particular bag, which is the sum of all the candies that were there. We'll take this equation and copy it down throughout the entire data set. And then we go with the fractions. Now we want to create a histogram. A histogram requires a set of bins and the actual values. So the bins are going to be how many, for example, how many of the candy bags have a fraction less than 10%, and then how many have them between 10 and 20%, and 30 and 40%. For this experiment, it is a good idea to have 5 bins. So we need to figure out what the appropriate bins should be. So what if I take a look at what the maximum value is that we find in our blue fractions? It's 0.42. If I take 0.42 and divide it by 5, then we see that our bins should be roughly 0.08 units apart. I'm just going to, for simplicity's sake, separate them into 0.1, 0.2, 0.3, 0.4, and 0.5. And that will get all of our candies. This number is probably going to be different for each one of the remaining colors. I will leave you to figure out what the appropriate bins are. Now, we want to figure out how many numbers in this column are less than or equal to 10. 0.10, 10%. To do that, we're going to use the function called countifs. Countifs gives us the opportunity to apply multiple criteria. For this first example, we only need one criterion, but for the subsequent ones, we're going to need 2. I'll explain that in just a minute. So countifs first asks for the range, and our range is going to be I2 through I36. And the criteria, in parentheses, less than or equal to sign, and then an and put in K2. So what that tells us is that the range that we're looking at is I2 through I36, and we're going to count if the value K2 is less than or equal to, or if the value is less than or equal to K2. And there are 2 of them. So far, so good. Next one, countifs. Again, our criteria are range is I2 through I36. The first criterion is going to be less than or equal to and K3. Now the second criterion, again, we need to put in I2 through I36. We have to be redundant here. But now we want to see if the value is greater than K2. Notice what we've done here is said is that we don't want to double count the 2 that we've already counted here. So the first part counts all of the values that are below 0.2, and then this second criterion will discard the 2 that are actually less than or equal to 1. And there are 10. We'll do the we can do the same thing for the subsequent 4. If we put our dollar signs, make appropriate use of our dollar signs, like so, then we will be able to copy this version of the equation down in the remaining 3, and it should work. We check. That makes sense. Good. So we've got the right equation. So we see that we've got 2 bags had a fraction of blue candies 10% or less. 10 bags had a fraction of candies between 10 and 20%. 15 were between 20 and 30, so on and so forth. Let's make a little bar chart of this to see if these data look like a normal distribution. Highlight, insert, column, bar chart. Oops, I forget that we only need one data set, so I'm going to delete that. And notice how this looks like a bell curve. It's fairly symmetric on either side. There's a little bit of a discrepancy here, but we also only have a very small data set. We probably need several hundred examples before we would see a very good, well-shaped bell curve. This looks pretty decent, and I would say qualitatively, the data for the blue candies do follow a normal distribution. You can now do this for the remaining 5 colors, and I will leave you to create those graphs. Be sure to adjust your equation in this column appropriately, and be sure to choose your bins appropriately by using the exercise that we did here.